Superficially, a label inspection system seems simple. You just point a camera at the label, program in some data, and off you go. Unfortunately, this sort of system probably isn't terribly useful. In all likelihood, will not work at all. Here we'll examine the likely technical issues in specifying a vision system to be operated by non-specialist personnel while ensuring 100% label verification, minimal false rejects, and producing highly accurate production data. The difficulties come into several different categories, which we'll recognise as optical, mechanical, print, data integrity, and audit. Here are some questions that will help define the system you're looking for. We'll elaborate further on, as sometimes the answers aren't immediately obvious. The main question here relates to codes of practice, which are quite reasonably demanding and will often define the system that you need. Here we will consider the difficulties of taking the picture. Fast-moving packs and small print or barcodes will need a shorter shutter speed, which in turn means you need brighter lighting, just with any other camera. The basic lights that come with a smart camera often won't be up to the job. Reflective labels will also pose a problem, as slight changes in pack positioning or angle, or ripples in the pack, will produce drastic changes in the image if the lighting is not designed well. Large labels need bigger lights to cover the area evenly, and strobe lights are brighter, but they're unpleasant for anyone in the area. Here we'll cover placing the pack under the camera and what happens to it afterwards. If you're fitting the camera and lights into an existing machine, you'll need to ensure that you can still access everything required for normal operation and maintenance. If you have roof lights or windows, you'll also need to ensure that direct sunlight doesn't affect the camera. The packs will also need to move consistently, otherwise the area the camera is viewing will increase and you'll end up needing a higher specification of camera. You'll need a sensor to accurately detect the pack. Sensor manufacturers will tell you how wonderful they are at detecting clear packaging, but the reality is that most of the sensors have issues and detect the product rather than the pack a lot of the time. You'll need to also ignore stray labels stuck to the conveyor, frayed belt edges, and other machine-specific difficulties. Many customers initially want to stop the line rather than go to the expense of rejecting a pack, but often the defects that occur may not be the ones they're expecting, so it's worth spending a lot of time checking what problems are occurring. For example, our customers often find they have random print defects that occur when a flow wrapper changes speed. Rejecting a pack presents its own challenges, as the pack may be fragile. Reject mechanisms for heavier or faster moving packs will need a substantial length of the line to be guarded. Packs that arrive damaged or out of position may be spun rather than rejected correctly, causing problems further down the line. You also need to think about reject confirmation and bin full sensors, especially if you're supplying to a supermarket. You need to consider if your print is always of good quality, and if not, how acceptable quality is to be defined. There is a fine line between passing a character with bits missing and failing the wrong character. For barcode reading, missing print lines both justify inspection and mean diagnosing results is difficult. Operators may question why an apparently good pack is being rejected. If you have older offline barcode readers, then they probably will not reliably detect missing print lines, as they do not have sufficient resolution. If inspecting text or barcodes, you need to ensure the system is set up correctly. It is of no use having the same person setting up the date coder and print inspection by hand, as the system will end up passing packs with the wrong date. This leads you on towards a networked system, which will by implication require a database. You'll then have to consider what happens when the network goes down, how to control data access and backup. The supermarket codes of practice for labelling offer good guidance here. By integrity we mean, is the system secure? All too often throughput targets tempt operators into disabling the inspection, for example by tampering with the in-feed sensor. You also need to ensure that the reject is actually rejecting, and that a full bin doesn't result in packs spilling out of the machine. Suitable locks will stop operators taking packs from the reject bin and putting them back onto the line. If the user interface is not adequately locked down, then operators can adjust tolerances so that it will pass anything or even disable the system. Finally, we consider audit. You may need to identify who is operating the system, what they are allowed to do, and tracing who did what. The same applies to the source data, where you may need a mechanism for authorizing, logging and scheduling changes. You may also need a way of recording system operation, so that if a fault does occur, you can trace back and find out how many packs were affected and why.